whatever we have discussed. Okay. So good afternoon, everyone. So in this today's lecture, we are going to learn about the modular mathematics, okay, which is the base for the major and the second category of the cryptography, that is public key cryptography. So in public key cryptography, the same key is not used for encryption and decryption. Rather, sender and receiver is having pair of public key and private key, and the different key are used for encryption and decryption. So the key sharing was the major problem with symmetric key cryptography. That's why in the modern cryptography, in modern application, you will not see symmetric key cryptography used nowadays. But whatever application you are using, they are using the public key cryptography. So the base for the public key cryptography is modular arithmetic. So let's start with very basic concept, that is prime number and the composite number. And you are aware of like how the number is getting formed. So 15 is nothing but 3 plus 3 plus 3 plus 3 plus 3. And you can have the prime factorization of any composite number, right? So you can write, how you can write for the 30. 30 is to the power 1 into 3 to the power 1 into 5 to the power 1. So that's how this is the prime factorization of 30, and you can consider this is the unique, right? Factorization is unique of that. So you can consider like this log will be the composite number, and its prime factorization will be the key, right? So 30 will be the log, and to unlock that log, we need to enter. Like you can visualize in front of you the digital log which we are having on the bags, okay, uh, traveling bags, and you need to enter the combination of number. So that digital log can be the 30, number 30, and how you can unlock that 30 with entering the combination of 5 into 3 into 2. Moving to next important part, that is modular arithmetic. So in this modular arithmetic, modulus operator, right? Mod is nothing but like whenever we are writing if we are writing 10 mod 3, okay, 10 mod 3. So what does it mean? It means you need to divide 10 by 3. This will be right. So whatever remainder you will be having, that will be the modulus result, right? So 10 mod 3, the result will be 2, right? So we need to understand here the features of modular arithmetic. Okay. So on upper side, we have plotted the numbers. On the downsides, on downside, we have plotted number like 0, 1, 2, 3, 4, 5. And here we have represented the modulus result of 3. So 0 mod 0 will be 0. 1 mod 3 will be 0 mod 3 will be 0. 1 mod 3 will be 1. 2 mod 3 will be 2. Then again 3 mod 3 will be 0. So you will found that the particular sequence is getting repeated in terms of modulus operator, right? And it is what? Guess what? It is between 0 to n minus 1. So Here the n is 3, right? N is 3. That's how the modulus operator is working, right? So the cycle will get repeat from 0 to n minus 1, result of modulus operator. Okay. And then when this is triple horizontal line, you will see over here for equal to, right? Two numbers are equal to, we are using this equivalent operator, but in case of this we are using, this is called as a congruent thing, right? So whenever the modulus results are equal, then in that case we are calling these numbers are congruent to each other. So let's discuss this congruent concept, right? Congruent concept. So now you can consider like which two numbers for the modulus 3 operators are congruent, right? So you can consider, right, 0 mod 3 and 3 mod 3 is giving the same result, that is 0. So can we say that the number 0 is congruent to 3 mod 3? Yes. Okay. Then if you do the same thing for modulus 2 operator, right? Modulus 2, then in that case we can say that number 3 is congruent to 5 mod 2. Okay. I hope you have understood it, right? What do you mean by the congruence? So how you can say that these two numbers are congruent to each other? Like whenever you are having 3 mod 2, and in the same way you are having 5 mod 2. Okay, 5 mod 2. So what result you are getting over here? 3 mod 2, what result you are getting? You are getting 1. And 5 mod 2, again you are getting result 1. In that way the results, modulus result are equivalent. In that way you are saying that these are congruent to each other. I hope this congruence operator is very clear to you, because this is very important, right? In the next thing, right? So for mod 2, we are having the result from 0 to 1. For mod 3, we are having 0 to 2, like n minus 1. For mod n, can you say? Yes, it will be from 0 to 8. So we can have the question on the same, right? So in cryptography, congruence, this is the symbol for the congruence instead of equality, right? And this is something which we have discussed, right? And again, in this case, we can say 15 is congruent to 3 mod 12, 23 is congruent to 11 mod 12, right? Uh, Moving on, right? So here few examples are given which you can solve and you can verify through this document, like 38 congruent to 2 mod 12, 38 is congruent to, whether 38 is congruent to 14 mod 12. Then moving on with the next concept, that is Euclid's algorithm. So Euclid's algorithm, like we have already discussed, we know that many times we have uh, computed GCD, greatest common divisor of the number, or HCF of the number. So how you are doing that with the traditional method? If the number is, I hope number is visible, I'll write over here. If number is 12 and 33, so what are the divisors of that 12 and 33? So these all are the divisor. And the next step is you need to have the uh, common divisor, and then you need to have the greatest divisor, and that will be your result. So in this case 12 and 33 GCD will be 3. The second example of 25 and 150, so here you will be having the divisors, you will be having the common divisors, and the greatest common divisor is 25. That's how the GCD of 25 and 150 is 25, right? Moving on, when the GCD of two numbers, here the number is 13 and 31, right? In this case, if GCD comma if GCD of that number is 1, in that case the 13 and the 31 is called as co-prime with each other, or um, they are called as the they called as the co-prime numbers. Okay, moving on, the what Euclid's algorithm to find out the GCD of the number. So what you have to do, you have to take this number as it is, a and b, and make sure that a is greater than b. Okay, whatever number you are having, the a should be greater. Like here in this case 33 is greater, so we will consider a as a 33. And here you need to write the remainder, right, whatever you are having after the division operation, and here you need to write the quotient. And then you need to perform like 33, you need to divide, like it will get divided by 12, and a remainder you have to write over here, and the quotient you will be writing here, and the swapping operation will get performed, like b will get swapped to a, then the remainder will get swapped to b, and you need to perform this unless you are having this, like b becomes 0, right, b becomes, and then whatever result you are having into the a, that will be your final result. That's how you will be computing the Euclid's algorithm. So the GCD of 12 and 33 will be number 3. In similar way, you can find out the GCD for 750. The first number, like is between the 750 and 900. So of course we need to take a as a larger number. So a will be 900, b will be 750, and the same process you need to apply. Divide and shift, right, until you are getting 0 into b, and whatever result you are having into a, that will be considered as your result, a GCD of two numbers. With the same way, if you are computing GCD of 252 and 105, you will be getting GCD as 21, right? So it's quite easy method. And if you go through with the algorithm, this is the algorithm for computing the GCD, Euclid GCD AB, and prerequisite is A should be greater than B. If B is 0, then we have to return A. So A is nothing but which store our result. Else, what we have to do, you have to recursively called this function with the swapping operation, that a is first parameter is b, and the second is the modulus result. So that's how this algorithm works. So here are the example with the a is equal to 50 and b is equal to 12. So you can compute the things. Moving on, like this is the second example. Then we can have like relatively prime numbers. Okay, is the concept we have discussed. When GCD of two things is are equal, then we are calling it as they are prime numbers or co-prime number, relatively prime or co-prime numbers. So same way, like if you are having GCD 1, then we are calling it as relatively prime. If not, then they are not relatively prime. Okay, so GCD of 83 and 19, right? So you can find out the GCD with the Euclid's method, and then if the GCD of that two numbers are 1 is 1, then we are calling it as they are relatively prime numbers. Before discussing RSA, one more concept I'll discuss, and again I'll come to the RSA. That is, the concept is nothing but the Euler's torsion function. Okay, so Euler's torsion function, which is denoted by this symbol phi of n, and what does it indicate? The number of positive integer less than n that are relatively prime to n. So what does it mean? With the example, it will be more clear to you. If anybody asks you to find out torsion of phi, then how things will work? Here n is equal to 5. So what you have to do, you have to start to find out from 1 to n minus 1 to n, right? Sorry, n minus 1. Here in this case n is 5. So what you have to do, last number will be 4. So 1 GCD of 1 and 5, 2 and 5, 3 and 5, 4 and 5. You need to find out GCD, and you need to check whether they are relatively prime. If GCD is 1, relatively prime, 1 relatively prime, 1 relatively prime. ऐसे कितने नंबर है? दिस इज 1 2 3 4. ऐसे कितने नंबर है जो रिलेटिवली प्राइम है? So these are the 4 numbers. So count, right? So quotient of 5 will be 4. Euler's quotient of 5 is 4. Quite easy, right? In similar way, if I ask you to find out the quotient of 11, so here n will be 11, and here we are having n minus 1, last number will be 10. So you need to start with the 1 1 11 2 11 3 11 4 11 5 11 6 11 7 11 8 11 9 11 10 11, and you need to check how many numbers are co-prime with that given number. So ऐसे कितने number है? So total we are having 10 numbers which are relatively prime to the 11. So that is our quotient of 11. In similar way, if if it has been asked that find the quotient of number 8, so again same thing, the last is the 7, right? So again you need to find, but in this case you will found that few numbers in between are not relatively prime with the number 8, like just say 2 comma 8 is not relatively prime with the number 8. So here it will not get counted into the Euler's torsion function. So ऐसे कितने number है? The first, the third, the fifth, 5 and the 7. कितने हुए total? 4. So Euler's 8 is torsion of 8 is 4. Number 4, right? So again, when the number is big, right? Number is big, finding this is very difficult. So there are few formulas were given, right? Criteria for n. Shortcut method we can say that, and readily available formula we are having to calculate the Euler's torsion function. When n is the prime, the Euler torsion function will be phi of n will be n minus 1. In what case? When n is prime number. And when this n is nothing but it is a product of two prime numbers. Are you getting? If I do 3 and 5 are prime numbers, right? If I do 3 into 5, okay, 3 into 5, 15. So n will be 15. So the condition is that n should be product of two prime numbers. In that case, what formula you can apply? P minus 1 into Q minus 1. Product of P minus 1 into Q minus 1. And this is for some another things, right? N is equal to A into B. A or B is composite. Both A and B are composite. Either A or B is composite, or both A and B are composite. In that case, this is the formula. But this we will not use for our like for the concept. For implementation of RSA, that second formula will work. So if it has been asked that find out the Euler's of 35, so you can consider that 35 is a product of two prime number, that is 5 and 7, right? 5 and 7 both are prime, so you can directly have the formula to find out the Euler's of 35, that is P minus 1 and Q minus 1, and that's how you will be getting 4 into 6, right? 5 minus 1 into 7 minus 1. So that's how you will be getting 4 into 6 will be 24. The Euler's, this is something, the shortcut method to find out. So what does number indicate? It indicates there are 24 numbers that are less than 35 and relatively prime to 35. I hope it is clear to you. And if with the manual method, if you are trying to calculate the Euler's quotient of 35, then what you have to do, you have to start to find out the GCD from 1 to 34, and then whichever numbers are getting like are co-prime with the 35, that you need to add together, count. So that is something which we have discussed, which we require. Okay. Moving on, the next concept, like finding the multiplicative inverse of numbered. So we know what do you mean by multiplicative inverse. 5 into 5 inverse is 1. How one can write 5 inverse? 1 by 5, right? So in the same way, a into a inverse will be 1. So how one can find out the multiplicative inverse in case of modulus operation? So here congruent operator is used. Okay, so 3 into 3 को किसके साथ हम मल्टीप्लाई करेंगे और मल्टीप्लाई करने का जो रिजल्ट आएगा that will be congruent to 1 mod 5. Now tell me, what is the result of 1 mod 5? It's a 1, right? तो 3 इंटू क्या करोगे और उसको मॉड मॉड 5 के साथ ऑपरेट करोगे तो रिजल्ट विल यू विल बी गेटिंग रिजल्ट 1. सो मैंने 3 इंटू 2 किया तो 6 मॉड 5 will be 1, right? If I do 3 into 2, sorry, my mistake. 3 into 2 किया तो you will be getting 3 2 जा 6. Okay, यहाँ पे आपने नंबर डाला 2. So 3 2 जा 6. So 6 mod 5. रिजल्ट क्या आ रहा है? रिजल्ट क्या आ रहा है? 1. हाँ, 1 mod 5 का रिजल्ट भी क्या है? 1. So 6 mod 5 का रिजल्ट 1 है and 1 for my का रिजल्ट 5. 1 mod 5 का रिजल्ट भी 1. So can we say that they are congruent to each other? Yes. So in this case, what is that multiplying factor which will give you the result as a 1, right? Result as a 1. That product multiplying factor is 2. I hope you have understood it, right? So what is will be that multiplying factor, right? Which will give more 1 mod 11. So uh, 2 into 6 will be 12, right? If you replace question mark with the 6, so you will be getting 12 if you are replacing this with this value 6. 12 mod 11 क्या आ रहा है? Coming 1. And 1 mod 11 क्या आ रहा है? 1. Yes, so we can say both the number are congruent to each other. So that multiplying factor is 6 over here. That is nothing but the multiplicative inverse. So what will be the multiplying fact inverse, multiplicative inverse of 3 mod 5? So it will be 2, 6, right? What is 6? That is done. What is multiplicative inverse of 4 mod 5? So it's 4. 4 into 4, 16. 16 mod 5 is 1. I hope it's clear to you. Next is, what will be the multiplicative inverse of 5 mod 10? 5 mod 10. So what will be the result? 5 mod 10. Hmm? Like what we can have over here? So that result will be 1. What is the multiplicative inverse of 5 so that you can have a result as 1? Okay. So how it is written? Multiplicative inverse for the 2 mod 5 is 3. Multiplicative inverse of 2 mod 7 is 4. In that way it is written. So find out multiplicative inverse using extended Euclid's algorithm. So try to understand the same rule, right? A and B, A should be greater than B. Then we need to put the remainder, then quotient over here. Then we are having extra terms over here, T1, T2, and the T. So what we have to points to remember, A should be greater than B, very sure. And this is what quotient is, what remainder is, that you are already aware of. And then initial value for T1 is 0, T2 is 1. This is initialization. And the T2's formula is given over here. T2 ka formula, what is the T2? Sorry, T ka formula. T is nothing but T1 minus T2 into quotient. That you need to write over here. And T1 is multiplicative inverse. T1 will be multiplicative inverse. So now let's do that with the numbers. So here we are going to calculate the multiplicative inverse of 3 mod 5. 3 mod 5 का multiplicative inverse क्या है, right? So same way you need to follow the rules. A should be greater than B. So A क्या होगा इन इसके केस में? A will be 5, B will be 3, remainder you need to write over here. T1 initial value is 0, we have discussed. T2 is 1 and T1 ka formula we know, right? This is the, sorry, my mistake, it's a T ka formula, T. Okay, T ka formula is T1 minus T2 into Q, and this is the Q, right? And the next thing is that, so putting the value into T, you will be getting minus 1. Moving on, you need to do the shifting operation. So how the shifting will be done? B will get replaced to the A, remainder will get replaced to the B, and T2 will get replaced to the T1, right? And then this T is getting replaced to the T2. You need to do that you are having until you are having 0 into the B, right? And whatever value the T1 is having, that will be your multiplicative inverse. So 2 will be the multiplicative inverse of 3 mod 5. So 2 into 3 will be 6, and 6 mod 5 will be 1, right? So that's how the multiplicative inverse is calculated. And so now we will go to the RSA, right? RSA algorithm. So in the RSA, RSA starts with selection of P and Q. So I'll discuss RSA in the next video.